Yaskawa.
The Technical Training Department of Yaskawa America Incorporated presents Adding and Configuring the EtherNet IP Option Card for Yaskawa 1000 Series Drives. Hi, I'm Steve Kaler. An option card can provide a communications connection between a drive and an EtherNet IP network, facilitating the exchange of data. In this program, we are going to examine the key steps to establish network communications using the SIEN3 option card for 1000 series drives. Specifically, we will explain and demonstrate how to install the SIEN3 option card, how to select your network topology for use with this card. We'll configure the Yaskawa Drive to accept and follow network commands. We'll set up the PLC to communicate with the drive. After that, we'll test the network operation. Then we'll enable DLR. And at the end of this learning module, we'll outline some troubleshooting techniques. Now, at the end of each chapter of this presentation, we'll ask you a few questions to review some of the major points that we've covered. Are you ready? Well, let's get started. Chapter 1, Installing the Option Card in the VFD. Let's look at Yaskawa's SIEN3 EtherNet IP option card and the other items needed to put it to use. First, you'll need a Yaskawa Drive that's capable of accepting one of the EtherNet IP option cards. The majority of Yaskawa's 1000 series drives are designed to readily accept these cards. You'll also need one of the 4 available EtherNet IP option kits. There are 2 different types of Yaskawa drives that the EtherNet IP option board can be installed into. We will refer to the A1000, P1000, IQ Pump 1000, and Z1000 as a standard size drive, and the V1000 as a micro-sized drive. For the standard-sized 1000 series drives like the A1000, you'll use either the SIEN3 or the SIEN3D, where the D signifies the dual-port version. For the micro drive V1000, you'll use either the SIEN3/V or the SIEN3D/V. When they have dual ports, the option cards allow you greater flexibility in network topology, and we will talk more about that later. The first step to installing a Yaskawa Ethernet IP option kit is to take a closer look at its contents. A typical kit contains the option card itself, plus the items necessary to connect it to the network. These include a ground cable, mounting screws, and an installation manual. A close examination of the card itself reveals a few important parts. There will be a connector with either 1 or 2 RJ45 ports, depending on the card you're installing. Just beside this connector is the card's ground point. Elsewhere on the card is a sticker showing the Yaskawa part number. And this part number is an easy reference point to make sure that you have the correct option card. Many of the Ethernet-based option cards look similar, and the easiest way to differentiate them is by that part number. Installing the option card into a drive is designed to be a quick and easy process. The installation procedure varies based on whether you're installing the card in a larger-sized standard drive, a smaller-size standard drive, or a micro drive, and we will address all 3. First, let's consider the larger-sized standard drives. With the drive unpowered and the bus capacitors fully discharged, remove all the sheet metal cover plates except the top one. Remove the keypad. Then loosen the captive screw that secures the plastic cover shielding the control board. Now remove the plastic cover. Locate the CN5A serial port on the control board. Line up the connector on the back of the option board, then press the board down into the serial port. Secure the screws that hold down the board with the left screw also attaching the blue ground wire to the board. Connect the other end of the ground wire to the ground terminal located to the left of the board. All of this is covered in the installation guide and comes with the option kit and is also available on the Yaskawa website. Reattach all of the covers and apply the decal to the cover plate as described in the installation guide. Installation in the smaller standard size drives follows much the same procedure, but the cover to the smaller drives is split in half, with both covers needing to be removed. The process to install the option board into a micro drive can also vary based on size. It follows the same basic procedure as for the standard size, except that the option board comes installed in a carrier and will replace the original cover of the micro drive. The basic steps are: remove power and allow the bus capacitor to fully discharge, remove the covers, attach the ground wire to the micro drive ground terminal, route the ground wire through the option cover, and connect it to the option board. Install the option board and carrier, and then replace the covers. Specific steps can be found in the installation guide. At this point, we should be ready to apply power to our drive with our option board installed. After power is applied, diagnostic LEDs on the card may illuminate depending on the card's current status. Refer to your installation manual for an explanation of the status of the diagnostic LEDs. Before you attempt to run the drive from the network, test run the drive in local mode. Once you establish that the drive itself is running correctly, you can proceed to program the drive to accept commands from the network. Before we move on, let's review what we've learned so far. Take a moment to answer the following questions. Question number 1. What does the letter D stand for in the Yaskawa part number SIEN3D? That's right, the D stands for dual port, as it has 2 Cat5 connectors on the option card. Question number 2. How do you ground the EtherNet IP card? Answer: the blue cable included with the kit should be connected between the drive's ground and the option card screw. Finally, question number 3. Should option cards be installed or reseated in a powered drive? No. The answer is, of course, no. Never. Only a fully discharged drive is safe to install or reseat an option card. Chapter 2, Selecting your network topology. Setting up a network requires the use of Cat5 cabling. In general, 3 network configurations, or topologies, are possible. The first of these network topologies, star or tree, requires the use of an Ethernet switch or multiple Ethernet switches. With this topology, the dual-port option card is not required. The 2 other network topologies, line and ring, do not require the use of an Ethernet switch or switches. However, both do require the use of a dual-port option card. DLR is possible only in ring configuration. Now, before we go further, let's define the acronym DLR. DLR stands for Device Level Ring. DLR is a Layer 2 protocol allowing for redundancy in ring networks while reducing the need for switch hardware and some cabling. It also provides detection and recovery of faults in the ring. If a communications break occurs somewhere in the network, connectivity is still maintained. DLR is only available with dual-port versions of the option card, which are the SIEN3D and the SIEN3D/V. DLR is enabled on Yaskawa's SIEN3D and SIEN3D/V option cards using the option card webpage. Before we set up a DLR network, we need to configure a supervisor. This needs to be done prior to connecting and powering on all devices in the ring. If we establish a ring without an active supervisor, it may cause a loss of communication to devices on the ring. Yaskawa recommends that all devices in the ring be DLR capable. If you need to add non-DLR devices to the ring, route them through a DLR capable device, such as a 3-port ETAP. Before we continue now, let's review what we've learned so far. Take a moment to answer the following questions. Question number 1. What type of cable is used for interconnecting an Ethernet network? The answer is Ethernet networks are interconnected using Cat5 cables. Question number 2. What does DLR stand for? You remembered. DLR stands for Device Level Ring. And question number 3, which network topology will benefit from DLR? Star, line, or ring? The easy one. Ring networks benefit from DLR. Nice job. Chapter 3, Configuring the Drive. The network configuration parameters for any Yaskawa Ethernet option card are located in the drive's F7 parameter group. If you want the network to assign your network settings, program F713 to either 1 for boot P or 2 for DHCP. If you want to use a static network IP address, set F713 to 0 for user-defined. You will then need to use F701 through F704 to set your IP address, F705 through F708 to set your subnet mask, and F709 through F712 to set your gateway address. Cycle power to the drive for the new network configuration changes to take effect. Confirm the network configurations by viewing monitors U680 through U691. From this point forward, this drive will only be accessible using this new network configuration. Use a Cat5 cable to connect the drive to your network. One advantage of an Ethernet-based option card is web access. The card can provide a web interface when queried with Internet Explorer or other common web browsers. To pull up the web page, type the IP address shown in monitors U680 through U683 into the address bar of your browser. When the connection is successfully made, the card's web page will be displayed. The web page displays details about the card, including its MAC ID, firmware version, IP address, and I/O diagnostics. There are additional pages that offer further diagnostics. An important step that is sometimes overlooked is configuring the Yaskawa drive to follow the frequency reference and run commands that are sent to it over the Ethernet network. To properly configure the drive to follow network commands, set the frequency reference parameter B101 and your run command parameter B102 to setting 3, option PCB. Okay, let's review what we've learned about configuring the drive. Question number 1. Which parameter group in Yaskawa drives configures the network settings of the Ethernet option card? The answer? F7 is the parameter group in Yaskawa drives that configures the network settings of the Ethernet IP option card. Question number 2. What must be done to the drive to make the network parameter changes take effect? That's right. The answer is to make network parameter changes take effect, the drive needs to have its power cycled off and then on. And finally, question number 3. Which monitors will always show the current IP address of the Ethernet IP card? The monitors that will always show the current IP address of the Ethernet IP card are the U680 through U683. Chapter number 4. Setup for network operation. Now that we've installed the Ethernet IP option card, wired it to our network, and programmed the drive, we are ready to set up the PLC to communicate with the drive. To demonstrate this, we are going to use Rockwell Software's Studio 5000 software. As we can see here, the PLC has already been set up and a project has been created. To attach our Yaskawa drives to the network, we right-click on the Ethernet branch under the I/O configurations and select New Module. Before we select how we can identify our Yaskawa drives to the Ethernet IP network, let's discuss EDS files. Some controllers require the use of an EDS file in order to add a device and configure it. An EDS file is a text file. It can be used by a configuration tool to provide a more detailed description of the device. This file can contain information about the device vendor, the type of device, and a description of applicable device parameters. EDS files for Ethernet IP cards are not usable with other types of network cards like DeviceNet. Note that an ODVA-compliant EDS file is required for conformance testing. No special registry tool is required. It's also important to note that the EDS file for dual-port versions of the option card is different than the EDS file for the single-port version. Make certain that you download the correct file for your option card. By now, you're probably wondering where to find the EDS files for Yaskawa Ethernet IP cards. Well, the latest versions of EDS files can always be found at the Yaskawa website. To obtain them, go to the Yaskawa homepage. On the main menu bar, select Drives. And from the drop-down list, navigate to the model of Yaskawa Drive you are working with, such as A1000. From the Drive page, select the Options tab. In the right-hand column of the Ethernet IP or Ethernet IP with DLR option is a link for the EDS file download. When setting up the drive in Studio 5000, the EDS file is not required. This is why we will be adding our drives as generic Ethernet modules. In the dialog box that comes up after we decide to add a new module to our Ethernet network, we need to select the module type. We click on the Catalog tab and type in EtherNet to help us find a generic Ethernet module. Select the generic Ethernet module and click on Create. We need to give it a name, so we'll type in A1000_1. For the COM format, select Data INT. Next, enter the IP address for the card. For this first drive, we will use 192.168.1.22. One of the helpful features that Ethernet IP shares with DeviceNet is the use of assemblies, a set of functions grouped for ease of device control. Once the assembly has been chosen, the PLC can repeatedly send and receive the information defined by the assembly in a polled type of information exchange. The Yaskawa Ethernet IP cards feature many assemblies for input and output, including some that are exclusive to our cards. Let's look at the extended speed-torque control input and output assemblies as an example. This chart shows the information that will be exchanged repeatedly between the PLC and the Yaskawa drive. For our example, though, we will select a simple but very typical input assembly, which is Input Assembly 71. The input assembly defines what basic drive status information is being sent from the drive to the PLC. Next, we select the output assembly to be 21. Output assemblies define what command information is sent from the PLC to the drive. Assemblies 71 and 21 are 4-byte assemblies, which is 32 bits total. So, we need to change the number of 16-bit registers to 2 for both input and output. We need to give it a configuration number, so we type in 1 and then click on OK. When the Module Properties box comes up, the only thing we will do here is set the Request Packet Interval, or RPI. For our demonstration, we will select 100 milliseconds. Now click OK. And there's the A1000 node we just set up. Now we're going to add a second drive, so we repeat the steps for adding a drive. As you add additional drives, the setup procedure is identical with the exception of the device name and IP address. Each drive must have a unique name for the PLC and its own IP address on the network. We want to add a second module, so once again we will right-click on Ethernet and select New Module. But this time, instead of going to the Catalog tab for a list of modules, we simply click on the Favorites tab. And there's our generic Ethernet module. We select it and then click the Create button. We'll call this one A1000_2. Again, COM format is integer data, and the IP address for this one will be 192.168.1.25. Again, we'll duplicate setting the input assembly to 71 and the output assembly to 21. We'll also set up the remaining parameters as we did for the first module. We'll repeat what we did for the RPI, changing it to 100 and clicking on OK. Time for another review. See how well you remember some of the major points about setting up for network operation. Question number 1. If an EDS file is necessary for a controller to identify a Yaskawa drive on the network, where can Yaskawa EDS files be found? The answer: EDS files can be downloaded from the Yaskawa website. Question number 2. Does an input assembly define what information is being input to the drive or to the PLC? The answer is an input assembly defines what information is being input to the PLC. And question number 3. When configuring identical drives on the network, what must be unique to each drive? You got that one. When configuring identical drives on the network, the name and IP address must be unique to each drive. Well done. Chapter 5, Testing the Network Operation. So, everything should now be set up. We can look at our controller tags, but the information here is not easily identified in Studio 5000. So, we're going to generate more descriptive tags using the Yaskawa Tag Generator program. The option cards in our A1000s are SIEN3. We are using integer data, so we'll click on that. And we set this up for the latest version of PLC firmware. We want to use these tags as global tags, so we need to remove the text from the scope field. We will need to name our nodes just as we did in Studio 5000, so the tags can be properly linked to the correct device. Select the same input and output assemblies we defined in Studio 5000. Now we create a file to save our tags to. We'll call this one Demo and click on Save. Then we click on Build. To set up the tags for our second drive, we just type in the name A1000_2 and click Build, because everything else is the same. It will append these new tags into the file already created for the first drive. Now we can close the Tag Generator program and return to Studio 5000. We need to import the tags we just created. To do this, we need to be offline. We can see that we are, as indicated in the upper left corner. We pull down the Tools menu to Import and choose Tags and Logic Comments. Navigate to where the Tag Generator file was saved. We were lucky enough to already be in the correct folder. And then select the correct file and then click Import. You can see we have now labeled our information with tags that are descriptive of the information that they represent, such as Get Input Status, which will show the status of the first A1000 drive. Examples of other drive information available are Fault Status and Forward Run Status. But the information we need to demonstrate network functionality of our drives is further down the list. We'll be using the Forward Run command and a set frequency reference. Those are for the number 1 drive. And down here are the same commands for the number 2 drive. Here is the forward run and the set frequency reference. Before we issue those commands, we first have to go online with the PLC. We go to the Path menu. There is no path shown, so we click on Who Active. We are connected via USB, so we click the plus symbol next to the USB to expand it, then select the PLC, and then click Go Online. In this example, we see that we already have a different demo loaded in our PLC, so Studio 5000 asks if we want to download the new demo. We click on Download to download all our new information into the PLC. Once that's done, everything looks okay. The green box indicates we're in the run mode. The first thing we can do is set the frequency reference. We simply click in that field and type in, for example, 3000, which will be interpreted as 30 Hz. If we hit Enter, I can look at my first A1000 drive demo and see that it's now showing 30 Hz as the frequency reference. I go to the second one and type in 2500, for example, hit Enter, and it changes the frequency reference of the second A1000 to 25.00 Hz. Now, we just have to give them run commands. We change the 0 to a 1 for the set run forward parameter, hit Enter, and now it's running. We do the same thing for drive number 2, change the 0 to a 1, and hit Enter. Once we do, we can see that the output frequency of both drives will update and show the current output frequency of each drive, proving that our project setup was successful. Well, let's take a moment to review testing the network operation. Question number 1. What Studio 5000 menu allows importing custom tags to the controller tags? Answer: the Tools menu allows you to import custom tags to the controller tags. And question number 2. After using the Yaskawa tag generator, which controller tag is the one for setting the drive's speed? The answer is, after using the Yaskawa tag generator, the set frequency reference, or setFreqRef, controller tag is the one for setting the drive's speed. Welcome to Chapter 6, Enabling DLR. For the next demonstration, we have our ring hardware already set up. The PLC is connected to one drive, which is connected to another drive, which is connected back to the PLC. Looking at the controller organizer, we see the controller EtherNet IP scanner inside our PLC. We right-click on it to go to Properties. In the Properties window, we click on the Network tab, and this is where we enable the supervisor mode. We do this because we want the PLC to keep track of our ring. If anything goes wrong, it will track the ring fault and not lose any functionality. As mentioned earlier, technically, you should enable the supervisor mode first and then make the final connection of your ring topology in order to avoid unnecessary faults. We click on Apply, and it confirms that we do have a ring. Our PLC's IP address is indicated here. Everything's fine, and no faults are indicated. At this point, we're going to create a fault by unplugging one of the cables. As you can see, the network status is telling us there's a ring fault. The software indicates where the ring fault occurred. This will provide you with enough information to locate the faulted connection. Even though we have a fault in the network, you can see that both drives are still running. This is possible because DLR has been enabled. If we had lost a connection without enabling DLR, we would have lost control of one of our drives. Now we'll plug the cable back in, and you see that the network status returns to normal. It still shows that a ring fault was detected and where that fault occurred, but everything is back to normal. If we want to, we can reset the counter back to 0 and click Verify Fault Location, because the ring is intact at this point. Here are a few review questions about enabling DLR. Our first question: how is DLR enabled in the PLC? The answer we were looking for is DLR is enabled in the PLC by using Studio 5000 software. Question number 2. How is DLR enabled in the option card? If you remember from earlier, DLR is enabled in the option card via the option card web page. And finally, question number 3. In our example, who was the DLR supervisor? Very good. In our example, the PLC was the DLR supervisor. Congratulations. And this is Chapter 7, Troubleshooting. If after completing the installation and programming steps, the drives in your network are not fully functional, use the following troubleshooting techniques to find out why. Troubleshooting must be performed by qualified personnel. Always keep safety first. Make sure that all Ethernet cables are securely connected throughout the network, and that there's no noticeable damage to any cables or connectors. A simple continuity check with an Ethernet cable tester is likely to reveal any wire breaks. With the drive unpowered and fully discharged, check to make sure the option card is seated properly in the correct port and associated cabling is securely plugged into the option card. Now apply power and observe the card's diagnostic LEDs. For a complete explanation of the proper status of these LEDs, refer to your installation manual. Improper grounding of a device on the network might also be the problem. To troubleshoot potential grounding problems, try checking the following 4 conditions that might be the source of the ground trouble. Make sure the device is grounded at the cabinet with a star washer. Run copper directly from the drive to the single-point ground. If there are multiple cabinets or machine sections, it may be necessary to install a copper braid between the cabinets. Check that the building ground rod installation meets specifications and local code. Now, in some cases, noise cannot be eliminated or a suitable ground cannot be made. In instances like these, a ferrite filter may be effective for cleaning up some of the noise and solving intermittent problems. Ensure that each segment is grounded with a single-point grounding connection. The option card ground connection must be installed. Checking the grounding with an oscilloscope can sometimes reveal a noisy ground connection that could be causing the problem. However, the oscilloscope isn't a perfect solution because using a scope to check a ground can be difficult. A slow scope of 300 megahertz or slower is unlikely to yield any useful information. If the hardware troubleshooting checks out, you can troubleshoot the programming. If the drive doesn't seem to run correctly when prompted by the master, the settings of the reference and run source parameters should be checked. Incorrect parameters will cause the drive to ignore any run commands from the master. Check the frequency reference command and the run command, B101 and B102 respectively. Also, make sure the network parameters, IP address, subnet mask, and gateway have been set to the proper values for your network. If the parameters are not set correctly, the drive will not accept commands or run at the intended speed. You can check the IP address of the drive by looking at monitors U680 through U683. For the subnet mask, look at monitors U684 through U687, and for the gateway, look at monitors U688 through U691. Monitors U698 and U699 display fault codes, which are particularly useful in detecting the causes of communication errors. Further information on fault codes is contained in the installation manual of your option card. For our final review, here are 3 questions about troubleshooting your network connection. Question number 1. What drive parameters need to be adjusted for the drive to be able to follow, run, and reference commands that are sent via EtherNet IP? Answer. The drive parameters that need to be adjusted for the drive to be able to follow, run, and reference commands sent via EtherNet IP are B101 and B102. Question number 2. Where should you look for an explanation of the option card status LEDs? Excellent. For an explanation of the option card status LEDs, check the installation manual. And for our final review question, what tool would be useful for detecting noise on the option card ground terminal? An oscilloscope. Yes, an oscilloscope is useful for detecting noise on the option card ground terminal. Congratulations. Well, we've come to the end of this training program, but it definitely is the end of our commitment to make Yaskawa drives and motion products the best in the industry. The commitment to quality continues in the way we work with our customers and with our vendors. It's in the way we train our associates. It means we deliver product on time. We answer questions quickly, and we never say we can't. Yaskawa quality is reflected in the effort our associates bring to work every day. To us, quality means doing everything we can to make our customers, partners, and employees' experience a great one. We commit to that. We make it happen. We can. Because to us, it's personal.